the introduction and the opportunity to present here today. I want you all to imagine a lake. The first light of dawn breaking over the water, the mist rising. Your line is tight. Your lure drifts perfectly. Suddenly, a tigerfish smashes your lure, making your heart stop, sending thrills down your body. The rush, the power, the fight. The reason anglers across the globe tries to come catch this tigerfish. Our tigerfish needs more than science. It needs people. Citizen science turns local anglers and communities to active contributors to the conservation of our biodiversity. So just to tell you a little bit more about this amazing fish. So this is, sorry, let me get the laser. By the way, there is a laser pointer for those that presented here that didn't know or needed it. So this is our African tigerfish. It's a little bit smaller than the species going up north into Africa, but it's still our top predator, similar to that of the Nile crocodile. They're ecologically important because they respond to environmental pressures such as altered flows, pollution, and habitat change. They're also important from a recreational fishing industry, as I just explained in the beginning. And our recreational fishing industry contributes more to our economy than cricket and rugby combined. And they're also important from a food source perspective for the local communities. So wow, we know they are great fish, but yet we still don't really understand the movement. We don't know if they have to move, what habitat they use, do they migrate, where do they spawn? We have no idea about this fish. We have some ideas, but we have no proof of it. And in the last 50 years, the distribution of tigerfish has declined throughout southern Africa because of barriers and altered flows. Because this species is very temperature dependent. So in the wet season, they can move up. But when they need to come down, the barriers block them. And they can't hide from the sudden change in maybe high temperatures or even cold temperatures. And if you just take habitat, for example, if you have altered flows and you only have shallow pools, they cannot go deeper to the colder temperature that they require. So catch-mark-recapture is a great method and is widely used to look at the movement, growth, and population dynamics. But in southern Africa, it hasn't worked on our tigerfish because they do not retain the tags very well. But even that little bit of tag retention can still provide valuable information for our tigerfish. So that's what we did. The aim of the study was to look at the movement and population dynamics of tigerfish in this lake, which I will zoom into in a moment. And we used catch-mark-recapture, catch per unit effort, and confiscated gill netting data to get an understanding of the movement and population dynamics. So if I zoom into the map, in collaboration with Mafungana Fly Fishing, we were able to tag 188 tigerfish in the lake. We focused on this arm because that's just where the operation was taking place. The tags had the website, sorry, it's not very clear, but it had a website on where local anglers was able to report the recaptured information. So we did dot tags, but because it was local anglers, they obviously didn't have, or we didn't have enough funding to provide them with a pit tag scanner, so only one of our recaptured fish was actually confirmed to have both tags. For the catch per unit effort data, so this company had 4 boats, but only one boat was big enough to tag fish, but they recorded all the fly fishing tigerfish that they caught for us to look at the catch per unit effort data. So we tagged across 6 seasons, in spring moving to winter, to summer, and autumn moving into winter, across 6 seasons in the 4 years. This is the percentage of catch over the size of the tigerfish, and you can see we tagged 188, if I missed to say that in the previous slide, with an average size of 1.8 kilos, the largest being 5.9, which again is big for our tigerfish, and the smallest being just over 500 grams. So lucky for us, we got recaptured data, and this is where I want you to pick your favorite colors. Please look at the map, and let's see where your fish moved to. Okay, so you can see that there was a range of movement between your species, between the individuals. So we had a total of 10 recaptures, which was a rate of 5.3% recapture rates. So if you pick the orange fish, which is here, you both moved the smallest distance and was recaptured the quickest. If you pick the yellow fish, you moved all the way to the other side of the lake. And the pink fish, I hope you saw it increased in numbers, because this individual was recaptured 3 times. Maybe it's smart, maybe not so smart, who knows? Okay, so just an interesting recapture was the green fish. So the fish looking that way is where it's marked. This is the recaptured location. And you can see it moved up the river. So we know tigerfish breed in the river with some evidence that they can breed in the lake. But irrespective of whether this fish breed or didn't breed, it still moved outside of the reserve, increasing its vulnerability to gill netting and other stresses that might be accounted for inside the reserve. It was tagged for about 246 days and moved 10.8 kilometers. There was an increase in weight, not necessarily length, but you can't really count on anglers' data necessarily. They always try to increase the fish based on the data that we saw. Looking at that pink fish that was recaptured 3 times, so the first recapture, it moved 1 kilometer in just under 600 days. The second recapture for the same fish was 440 days after the first recapture, moving 3.4 kilometers. And the third recapture for that individual was 25 days later, moving only about 300 meters. The idea that we have here is maybe it's a feeding strategy. Maybe they are following the boats that discard the leftover baits, because people fish with sardines and leftover baits. And that is similar to what McCord and Lambert found in 2019 with the Zambezi shark in the Breda estuary. Looking at the catch per unit data, you can see there's a nice cycle happening, with the blue being spring, autumn being the reddish pink color. And this is probably due to temperature or their breeding season being, like we heard in the previous talks, they're moving more just because of the time of the year. But because there's no independent data in this lake, we don't really understand the relationship between the catch per unit effort and the population size. So is this maybe indicating a hyper-stable relationship? Are we catching the boulder population and actually this population is declining underneath? We have no idea. Then we get to gill netting, which is a big problem in the lake, and it's really widespread. And you can see here, this is one of the fish we caught. That is still a piece of filament of the gill net stuck to it. And you can follow the scar up on the side of the fish. Did it lose its eye with the gill net? I cannot confirm that. But it's definitely a big problem in the lake. So we used the SAP's water wing data. So they've started operations 2016 where they monthly confiscated the gill netting. And they've confiscated 134 kilometers. And just to put that in perspective, that's further than not Port Elizabeth, the other one, East London. It's London's airport. So if anyone's driving there, just imagine all that road, there's still gill net left in that river, or in the lake, and how many fish get caught in. And with the fish that was captured, that seems little, but you must remember that these gill nets was actually removed from the banks. And this was during one operation where the net was actually in the water, and 63 tigerfish, which is endangered in South Africa, was captured. And tilapia, which I think is that's how it looks for those who don't know, is the main food I think they're looking for. And in one event, there was 500 tilapia that they reported, and 151 in the second event. So when we looked at the reported data from it, this is gill net intensity in kilometers over the years, with the different dots being the different operations. Some of the gaps was because the gill netting data wasn't reported in a way that I can do intensity, but there was some months that they didn't go out. So initially it looks very promising. You know, in 2018, there's a nice decline going from 2016. But then COVID happens, and the gill netting increased. The gill netters also started to change the way that they use gill netting. Rather than having floats, they started to sink the net. So it got difficulter to actually see them. We continue. They start going into protected areas. They start leaving piles of catfish on the lake. Was it because they left the net longer? Or is this indicating this is starting to be more a commercial thing rather than a subsistence fishing for people's just food having and just to have food, but selling it? That is catfish. And then as we go on with the years, we see major illegal camps coming. The processing camps moved uphill initially, but now they're literally 500 meters from the camp. They don't care if anyone sees them processing their fish next to the bank. And they also started to go gill netting at night, showing this almost evolutionary arms race between the poachers and the police force. So my question remains, and I hope I can give it to this audience, is I don't know if the tigerfish population is declining, if it's stable. Does the low recapture rate mean it's just a method, or is it indicating something? The opportunistic feeding behavior, is it because all the prey is getting caught in the nets, or they're just opportunistic? Is it a hyperstable relationship, the gill net intensity? And if we do lose this species, it's not, so I forgot to mention, but this location is the most southern distribution of the tigerfish, and if we lose them there, they're gone, moving up in their range. And there's so many people from economic perspective that rely on the tigerfish in this area. And we see that the movement data is really variable. You saw the different locations the fish move to, and we need to understand where they're moving, why they're moving, so that we can better manage and conserve the tigerfish in this lake. And I think citizen science is a great way to contribute to the conservation, and that we can use catch-mark-recapture studies in the tigerfish. I just want to thank all the funders and all the anglers and everyone that was involved in this project. And yes, I please give the floor to you and to help and say anything that you can to help conserve our species. Thank you.
Angelica, that was a really, really great talk.
Thank you.
I mean, your recapture rate is actually not that bad. So, you know, with the ORI Cooperative Fish Tagging Project, that's tagged like 300 different species, and overall, the recapture rate for all of them, a rough average is about 6.7%. So your
Okay.
6% is actually pretty comparable, and I think it's just, you know, what this method is, you know, the chances of
Yes.
recapturing. So just something to think about.
Okay.
In comparing with other species and other systems.
Okay, wow.
Yeah, awesome talk. Yeah, so much more work can be done on freshwater fishing. It's really awesome to see that thing. I was curious in terms of, were you using dart tags or T-bar tags?
Dart tag, sorry.
Dart tags.
Yes.
That's cool. I thought that looked like a T-bar applicator, but I think it's your bit tag applicator.
The bit tag, yeah. So they did do a previous study on the T-bar tags, but that didn't work. Yeah, but the dart tag seemed to work. So another study from Francois Jacobs did test whether dart tag retention, but the thing is they were in the small pond, and I think the volume of like the size and the amount of fish that was there, the density was so high, they like bit off the tags or rub against the walls. So I think having it in a lake, and I also think a river is maybe not the best option for dart tagging because of the other study in Kruger. So they go up and you're never going to see them again, where this is nice and isolated in a sense, but a big enough water to keep the tag. But that's what I don't know. That's what I just think.
And then just to add to that, is there any scope to start using electronic tags?
Funding, yes. If anyone's available, I will take it.
Part of the idea is to, in the future.
Yes, so the plan would be to use radio tags. So there's a study in Jozini where they want to look at how the crocodiles move, and they use a similar system. So if we can, it's the same infrastructure. So then we can add the tags, but yeah, funding at the moment is just not available. Yes, definitely.
Yeah, well, let's go. But
Thank you.
Angelica,